Hi, this is about number 8 over there, and they have this really great hint here. So I'm gonna write down the hint, and then I'm gonna stick in the values that they've given here. All right. So first I'm gonna write down the hint, and then I'm gonna arrange it so that I can stick in the values. I can't really stick in the values directly because some of these values are ratios rather than values, just raw measurements. Okay, so this is the competitive inhibition. I wonder, hey, what textbook are you guys using? This usually, in my class, when I was doing this at a community college, we were using the Nelson and Cox Leninger Principles of Biochemistry or something like that, and they didn't have this expression here. They just put alpha, and that was this whole thing. So I would like to know what textbook you guys are using, because that might be useful for my class too. I'm not teaching this class right now, just in the past when I taught this class. Okay, so the initial rate decreased to 1/3. So this decreased to 1/3. Now, they don't tell me what this is, and they don't tell me what this was. It just decreased to 1/3. So the new initial rate is like 2/3 less than. In other words, it's just 1/3 of the original initial rate. So what does that mean? That means the new initial rate, I'll call it V naught prime. The new initial rate is 1/3 of the old initial rate. So V naught would be the initial rate, and V naught prime would be the new initial rate. That ratio, that is 1/3, okay? But see, this is still V naught. So V naught, so I need another V max here, S over, okay, let me make this bigger so it's easier to see. So I'm trying to draw a ratio here for you. Ki, Km plus, so this is the inhibited V naught, and that's V naught prime. All right, so the inhibited V naught over the original V naught should be 1/3. The inhibited V naught over the original V naught is 1/3. So this is the inhibited V naught, and right here, this is the original. This is the not inhibited V naught, okay? And so that is just Km plus S, right? Right. So this is the inhibited V naught, formula was given, and the uninhibited V naught, which is just Michaelis-Menten, unadulterated Michaelis-Menten equation. So that is V naught prime, this guy, over V naught, this guy. That equals 1/3. All right. Now let's replace stuff in here. So the velocity at 0.2 millimolar substrate. 0.2 millimolar. So substrate is 0.2 millimolar. Substrate is 0.2 millimolar. Substrate is 0.2 millimolar. Substrate is 0.2 millimolar. Great. What else? 1.2 millimolar competitive inhibitor, right? So competitive inhibitor, this guy right here, this is 1.2 millimolar in there, 1.2 millimolar. And then dissociation constant for the inhibitor binding to the enzyme is 0.5 millimolar. Ki is 0.5 millimolar. Okay, Ki is 0.5 millimolar. Put 0.5 right there, 0.5. What is the Km? Okay, so this is just now a math problem, all right? So this is a little gnarly because of the way I've drawn the ratio here. You can redraw it, and in fact, I will redraw it for you now so that it's easier to see. So this is equal to the top times the bottom reciprocal. I mean, the reciprocal of the bottom, right? This is like, when you divide fractions in middle school, you do the top. This is the top. All this is the top. 1 plus 1.2 over 0.5. Now 1.2 over 0.5 is 2.4. So 1 plus 2.4 is 3.4. All right, so 3.4 times km plus 0.2. All right, now that's, so this inhibited v naught prime divided by original v naught prime is equal to inhibited v naught prime times the reciprocal of original v naught. So here's the reciprocal, km plus 0.2, and that's divided by 0.2 v max, 0.2 v max. Now, as always happens, or as very often happens in science, the math really works out nicely. So those things cancel out, and now we have 1/3. Remember, that was the ratio. 1/3 equals, and I'm going to copy this stuff down. 1/3 equals km plus 0.2 divided by 3.4 km plus 0.2. I'm going to cross multiply the way you used to do in middle school. 3.4 km plus 0.2 equals 3 km plus 0.6. All right. Now I'm going to collect the terms the way you did in 8th grade or whatever, right? So 0.4 km equals 0.4, and so km equals 1. And the units that these biochemists like to use is millimolar. All equilibrium expressions and rate laws are written in using millimolar concentrations, and then they give their, this is just a pet peeve, they give their equilibrium constants, the dissociation constant, even a Michaelis-Menten constant, they give it units. I don't understand why they have to give it units, but that's the answer. These biochemists, they're so strange. Why would they do that? Why would you give that units? Oh well, that's okay. So that's it for this video.